Just kind of a brief introduction. Traditionally, I've been a single-man ops team for most of my tenure, small business or startups. So I don't have access to a lot of things that larger corporations do, whether it be money, headcount, time, that kind of stuff. So what I'm going to do here is essentially kind of give you a summation of everything that I've learned over the past 4 years of me working with Shep, doing service orchestration, tell you kind of how it's been in the trenches, and then I'm going to do a live demo, end up with a running MySQL replication cluster at the end of this, and kind of leave you hopefully with the idea that you can take what's already out there, build upon it, and move forward and do greater things. This entire talk is in the GitHub repo along with the demo. Please don't everyone type Vagrant up at once. We will kill the Wi-Fi. But later on you can play with things and go as you will. So just kind of a couple little jokes I like to make. As we work with all of these tool chains, layers of virtualization, infrastructure, software as a service. It kind of feels like turtles all the way down. So I like to take the simplest unit as you can, look at it as an individual building block, and then kind of move forward. If you try and take all of these tools as a suite and look at them, it's going to be a little confusing. Second part is kind of as the culture and innovation drivers in our industry, sometimes it feels like we're on a hamster wheel all the time. I just want to let you guys know that it doesn't have to be like that. If you stand on the shoulders of giants, you can do a lot more. And I wrote a little haiku here. Do not spin the wheel, stand on shoulders of giants, share the work with all. And that's just kind of my philosophy. Everything that I do is open source. If you have additional questions for things that I have done that are not within the scope of this, I will gladly flesh that out. Again, just a little bit of perspective. I've been heavily involved with Chef and Amazon for about the last 4 years. I started off with no vendor lock-in, right? I wrote the entire workflow distribution system from scratch. Figured out that it was really a lot of overkill. Have kind of since dialed it back to a suite of offerings, not a monolithic system. A lot of people talk about web scale. I've got 8 machines, but we get about 1,400 new customers per day. So when you hear web scale, it's a little different to a lot of different people. I have concurrency and throughput, not necessarily large clusters of machines to manage. Again, a lot of this is driven by budget, headcount, time, and in the software as a service arena, SLA constraints, right? We have to sign a contract with our customers, keep our service up. It's kind of hard to do that when you've got 3 guys. So we end up kind of outsourcing a lot of things. I've been primarily on Amazon, although a lot of my friends are with Rackspace. They do have a pretty good public cloud offering now that will allow you to do model-driven infrastructure. Some of the focus here, again, providing SaaS internally within your organization. Let the web devs have a nice scalable database cluster, no SQL storage, whatever the case may be. A lot of white paper implementations that Amazon suggests are just too expensive at the low margin, high throughput volumes that we're doing. So I end up having to kind of do a little bit of service orchestration on my own, simply because we can't afford to offload that. And so that's where a lot of this comes from. I just want everyone to realize that all of this has been done with existing community cookbooks. Done a little bit of lightweight resource provider work, no templates. We've got a wrapper cookbook, and so it's just taking what's already there, whether you like the community cookbooks or not, making them better, making them do what you need to get your business logic moving forward. So what I'm going to do right now is actually kind of switch over here, and I'm going to start a run. Yeah, I know. I'm going to move it back. I'm sorry. I've either got one or the other, and this is mostly just so that you guys can can look at things in your own time, and also as a proof of concept just to show that it works, right? So I'm doing some hacky stuff here. I've got Chef 0 set up on a local IP so that my cluster members can talk back to it and share state between the two. But essentially what I'm doing, and I've got the description here, is I'm using Chef Server as a metadata service to essentially hold state and be a state machine for everything that's going on. So kind of while that's running in the background, I'll continue to talk about different things that are going on over there. One of the big kind of things with software as a service a lot of people don't think about is your entry points, right? You spend a lot of time doing service orchestration, making sure that your cluster config is up, machines are running, things are accessible. What about auditing? What about billing? What about reporting? All of these things I've traditionally controlled through a funnel, some sort of REST API front end, right? My big suggestion is when you start with this, go async from the start. We outscaled Bodo very quickly. It just did too much blocking within our infrastructure. So as you kind of think about where the customer touch point is going to be, you know, do your best to kind of pre-scale that a little bit. Dog fooding is really important. If your admin panel drives the deploys, then Sugar CRM or Salesforce or any number of other things could do this as well. So doing that from the start is, you know, really important. As far as architecture design goes, I've gotten a lot of different architecture requirements in my day. Most of them are a little bit grand, if you will. I've spent a lot of time writing code, doing a lot of testing for global synchronized deployments, right? In the end, we always end up running back in a single region across multiple availability zones. These are very Amazon-specific terms that I'm kind of using, but this is, you know, where my world has been. Definitely overscale your CPU and your compute and storage before anything else. I'm sorry. Scale your network before CPU and storage. It's really easy to add nodes, but when you've got a saturated pipe and you're under duress, you've got a user fire hose coming at you, you can't turn that off. It's really hard to fix a network problem compared with a lot of the virtualization that we have access to. A big note on security and complex systems interactions. If you blindly take best practices of multiple communities and combine them together, they are not necessarily holistic best practices. The one example that I like to use is using Amazon IAM instance profiles. It's kind of a little service on the back end for Amazon that swaps out your API credentials for you automatically. Well, if you combine this by just you know, including OHI, which a lot of cookbooks rely on, the OHI EC2 plugin will take those metadata credentials and store them in Chef Server, right? So what this means is your web node is now an attack vector to be able to unmount, remount drives on your database machines, you know, any number of things depending on how you have your API system set up. A little bit on responsive scaling. A lot of the talks here this week are you are the oracle, right? Chef Metal is great for doing convergence runs, multiple chef runs in linear succession. The only problem is I personally have never had control over that. And so what that means is, you know, I do a lot of auto scaling. I don't know how many machines are there at any given time unless I check. So it's really hard to kind of predefine these things. Some of the things that I've learned over time, not enough people seem to leverage chef handlers and the exception handlers, right? These are very important things. When you have a deploy fail, how do you know that, right? Especially when you're working with large clusters. Sometimes people do integration tests across a load balancer. Well, you get a 1 in chance of encountering that error. So it's really good to not only know when a deploy fails at the begin, but also to do periodic checks. And so what I end up doing is taking a special recipe that I run with chef client-o so that it doesn't get saved. and I put that in the cron tab. And why do I use Chef to do that? Well, because I've already built in all of my reporting and metadata and everything into Chef, so it just seems natural to kind of run that on a reoccurring basis. Especially if you use hosted Chef, cleaning up your nodes is very important, especially if you have kind of high fluctuation scaling events and you're actually using Chef within that portion of your infrastructure. If you've got things coming up and down a lot, it's honestly better to potentially bake an AMI without Chef using that, just because you're going to run into race conditions where your services are not in the coherent state that you'd like them to be when the machines start receiving user traffic. I use SQS and PyChef to do this. I've worked for Python shops for the past few jobs, so that's just what I use. The AWS SDK and the Fog Gem are really great for doing things like this as well. This is kind of to get to the meat of everything that's going on here. So I'm using node attributes in Chef Server for a state machine. I'm using cross-node resource providers and the concept of item potency to provide logic gates, right? So essentially, do some Chef Server searches for, is there a master that matches my metadata? Is there a slave that matches my metadata? Has action A occurred? Has action B occurred? These are very simple kind of binary states. One thing that I learned very quickly is if you want to use Chef Server as a metadata store, you have to keep it small, right? Depending on the cookbooks that you use, there may be node.saves that occur in random places that can potentially send large amounts of distributed traffic to the Chef Server at any given time. Again, this is not meant to be Zookeeper at CD. This is a poor man's service. Most of the time when I'm dealing with things like this, either I am the sole owner or it's a very small team and we simply don't have the cognitive resources, if you will, to start building very complex systems. Doing a lot of the things that I've done here has gotten me pretty far in the world as far as software as a service. If you go and look at the code that I have, it's only around 350 to 400 lines of actual Chef DSL. There's a small amount of Ruby code in there and a couple shell execs that happen. But for the most part, it's just adding another layer onto the existing community cookbooks. So, resources, right? Do you know when they changed? Do you know how many changed? Is your business logic in a resource? I see lots of kind of shell and script execs for custom logic. Go ahead and put those in a resource provider. That's going to allow you to treat this in a holistic manner. You'll be able to report when it changes. You'll be able to cross-notify resources. You can do things like whitelisting changes. Very frequently you have different levels of service or support that will interact with the software as a service system. So whenever that happens, it's really nice to kind of whitelist changes that are going to occur. Traditionally, this is done through an admin panel or something like that. And let's say you would like to potentially add a customer. Go ahead and build that into your integration tests through a metadata store so that when Chef Handler runs reports that in number of resources just changed, that's something that you were expecting. And if you weren't expecting, go ahead and alert an error on that. Tenancy, depending on kind of what service you'd like to provide, there may be any number of different combinations of both service and customer tenancy within those services. There's the multi-tenant, which is, let's say, Elasticsearch or RabbitMQ, where the service itself is designed to be a cluster. In general, I take a Chef environment per major product version. We started off production, staging, development, that type of thing, but what does that really mean when you have n number of live versions that you have to support across the customer set? And so by having a Chef environment that's kind of related to the major version of your product really gives you a way to categorize and identify and makes migrations and upgrades a lot easier. For single tenant instances, such as a MySQL cluster that's for security or compliance reasons, you know, a single stack install for a single customer, I in general include roles to denote kind of what the machine types are. But as everyone knows, roles cannot be versioned, so it's not necessarily a great idea to use those for major classifications. I simply use it for the ability to kind of tell what type of machine in a cluster is going on. So backup and restores. We've considered everything Chaos Monkey from the start. It can come, it can go. This, as an architectural standpoint, will allow you to implement spot instances or any number of other things in your infrastructure, and not just, you know, recover from errors, if you will. Usually we group low I/O utilities and services on a common mount point, that being kind of, you know, logging, just general system services, if you will. For high I/O, such as the actual RabbitMQ or Elasticsearch data store, go ahead and RAID 0 or prioritized IOPS, whatever kind of bandwidth you can throw at that, right? The file system you should use should definitely support freezing and thawing, especially if you're doing relational database work. I've traditionally used XFS. I know there are a number of other file systems that will support snapshotting. Go ahead and snapshot according to your risk management. So I've snapshotted anywhere from 10 minutes, 30 minutes, an hour, depending on the throughput of the application. I've never necessarily had an issue with service blips at that level. However, I have not personally dealt with, you know, sub 10 millisecond kind of, you know, response issues, right? And so again, just like the integration testing, the snapshots is done with a recipe that's done on a you know, kind of non-saved run list. And again, this allows you to leverage the Chef exception handler and report handler so that you know when snapshots occurred, when they failed. I actually do my snapshot cleanups in a distributed manner as well. Essentially, I've centralized all reporting and decentralized just about all actions. Again, to kind of go back to the support component, right? These machines are heavily automated. At some point in time, a human may end up on one of them, depending on the software as a service that you're offering. One of my previous positions was offering essentially single stack Snowflake installs for every customer. And so because of that, we allowed them to install audited code. Well, we installed, but audited code would end up on the machines that were not code that we owned. And level 2 support did occasionally access these machines. So one thing that a lot of community cookbooks already do, but I don't see enough of, is template headers, right? Make sure that someone who is not an operational engineer that looks at that file understands that it's an automated templated file and it may or may not retain those changes. Again, going back to Chef Handler, anytime a template changes, right? These are your service configuration files. You want to know when those change. Sometimes things need to be done by hand, right? Out-of-band actions, business logic, any number of things. So instead of notifying a service resource for a restart, why don't you go ahead and notify a custom resource of your own that may open a ticket in the change management system, you know, fire emails, any number of things like that. You'll get a lot of pushback for CLI access from support. Give them an API instead. This may or may not fly within your organization, but I've found that in general, most tasks that are wanting to be done are either diagnostic or relatively finite. Someone's not hopping on a machine, figuring out a very, kind of esoteric problem and then solving it by hand. They're just looking for additional information that hasn't quite been exposed yet. So workflow. I use Test Kitchen, Chef Spec, Server Spec, and Busser. Busser actually SSHs into the machines and runs unit tests of the code that has been deployed from the cookbooks. Very, very kind of important step for me as far as that goes is multiple layers of unit integration testing. I can't say enough about the Amazon product suite, CloudFormation, Autoscale Groups, S3, SQS, and Chef. I've pretty much been able to do anything anyone has ever asked me to pull off. A little bit of glue code, whether that be Python or Ruby or even Bash, depending on what the customer is comfortable with. As far as AMI creation goes, one thing that I like to do is have a cleanup recipe. So what I do is any unique information that is kind of snowflake to that node, right? Whether it be setting custom host names that are specific to a customer, anything like that. Go ahead and run that cleanup recipe to remove any idempotency kind of log files that you've put down, potentially check config or stop services so that when that machine boots and it doesn't quite know what its config should be, you're not just auto-running services that haven't properly been configured. A little bit on kind of some, fancy stuff, right? You can go to your CTO, tell them that you're practicing ITIL and IPAM. You can do change management and change detection with this. Security audit event reporting. PCI, HIPAA, FedRAMP compliance, right? If you build this in a holistic manner, you will already have the reporting that you need for all of these things. And kind of out of the box get you a lot further down the road than I think you would normally get. A little bit about MySQL stuff in specific. MySQL I've done in the past single tenant or multi-tenant in that it would be a single customer or multiple customers on the same machine. MySQL itself can handle the authentication for that, it can handle the namespacing. You're still going to want this REST front end to be able to do things like your audit reporting. If you happen to need formatting or sanity checking, that obviously is a great place to do that as well. One of the first things that we learned as far as customer billing is concerned, how do you really know the size on disk of the databases that you're working with? If you're doing InnoDB, there's file per table. Percona has a pretty decent tool set to support kind of table level analytics. And all of these things are very useful for capacity planning, right? At this point, we're no longer looking at a machine level running out of disk. We're looking at multiple customers in contention competing for all of that same disk space. So we want to be able to know if we need to move a customer to their own stack, move some smaller customers to a common stack, those types of things. Go ahead and put a caching offer in place. You can do this with the Memcache plugin within MySQL. You can go ahead and put just a small amount of logic in this REST layer, but that's going to help you way down the road, and it's going to help you scale and grow a lot quicker. Talking about RabbitMQ. As it is designed to be a clustered service from the start, it's a lot easier to deal with than the MySQL replication. So essentially all you have to do is a chef search to find other nodes that are kind of members of your cluster, adjust etc host for your fully qualified domain so that they can talk to each other. Depending on kind of your business case, I, in general, kind of use knife SSH and some different things to issue RabbitMQ level HA commands on the machines. You can namespace all of your queues, but it's much better to kind of do it at a customer level, right? Especially when it comes to compliance and non-technical people kind of understanding the barriers and different kind of levels of security that you have. As far as resource balancing goes, depending on your disk backend, you can have high throughput queue users affect other people on that same machine. So again, kind of going back to the capacity planning, these are all good things to really pay attention to. As far as Elasticsearch goes, the Elasticsearch AWS plugin and Cookbook are really awesome. Multicast doesn't work in Amazon, but inside the data center it does. That works by default as well. I can't say enough about how awesome Elasticsearch is and how easy it is to use and administer. Most of your effort is actually going to be spent managing and expiring your indexes according to whatever business SLA retention policy that you have. It's not really going to be spent running and paying attention to Elasticsearch. So again, just a couple notes on moving customers around. Unless you have a single stack install or a just crazy vertically scaled kind of homogeneous cluster, you will find yourself shuffling customers around to different configurations. It's one of the only few ways to kind of remain price competitive and resource competitive to take advantage of new product offerings from infrastructure providers. As far as upgrading Elasticsearch goes, as long as there are no breaking changes, it really is as simple as killing a node and bringing up a new one with a new metadata attribute for the Elasticsearch version set. Done it quite a few times, never had any issues. So a few notes here. My example that I'm going to kind of revisit here, it takes about 15 minutes to run a full convergence on multiple nodes. I put everything in a plain text data bag. Don't do that. Never put secrets in a node attribute. All nodes can see other nodes' attributes. What I end up doing is a encrypted data bag secret per node type, not even per customer type. And we store these in S3 and kind of use some user data and CloudFormation stuff to manage pulling those down. And if I've talked about Amazon things and anyone wants more information about that, I'll be at the Amazon Birds of a Feather later. I drive pretty much all of this with Amazon. But yeah, don't reuse the same encrypted data bag key across multiple nodes. You'll just be able to decrypt the other node's data. So all of the code that I wrote for this was 100% for this demo. Took me about 2 sprints, probably about 24 hours in total. And so, of course, I've got some experience doing this, but I just want to reiterate that there is so much from the community that already exists that does so much. The trick is identifying the minimum viable product you have to produce to overcome deficiencies and connect the pieces. All the glue code that I've done with this is Python and Bodo, just because that's what I've traditionally done. All of this could be done with Bash or Ruby or pretty much anything. I've got an appendix here, so I have links to this talk. I have links to the glue code for doing kind of bounce back machines that'll go down, come back on the restore, managing your node lists, and then a little plug for an open source project I've been working on, a single stack operations machine. So as I kind of mentioned earlier, I've decentralized all of my actions, but I've centralized all my reporting. Can't say enough about Kibana in combination with Elasticsearch. If you output with your Chef handler in JSON format, all of this will magically get indexed for you, searchable with graphs. There are now alerting layers on top of Kibana that you can add. A lot of great things that you can do. A few kind of mentions about other things that are going on in the community. Chef Metal kind of deprecated a lot of the work that I actually did for this talk, but I wanted to keep going because, as I'll show you, all of what happened was essentially kind of externally driven from anything of the Chef ecosystem, meaning that you could do it with Rundeck, you could do it with CloudFormation, you could do it with any number of things. A lot of what I've done with the state machine can be done with enterprise push jobs. I've never been part of an organization that could afford such things. A lot of the code that I've written, Poise, is a good framework to kind of get started, doing this in a more reusable manner. And then kind of going back to the instance profile and OHI EC2 metadata. Citadel with SafeNode comes out of the Balanced D guys. I don't know how most people's Amazon Chef infrastructures have been Audit Compliance certified because of this kind of centralized architectural issue. And they're the only ones that have really done anything about it to address things. So I'm going to pull back up this window. Find the mouse. I forgot to pray to demo gods, it failed. I'm not sure if it was Wi-Fi or what, but I can attempt to redress this, or I was going to start kind of opening things for questions. I know I went a little fast and kind of covered a lot, but I wanted to leave time for anyone that's currently doing service orchestration that would like to ask either a specific question or potentially have the opportunity to let other people know what you're doing if you think it's better. Sure, yeah. So this is getting a little bit into kind of Amazon-specific territory, right? But I do a combination of things. We watch kind of... Oh, sure, yeah. So he mentioned scaling actions. Upscaling's easy. How do you downscale? And how do you take care of that, right? Resource cleanup, that type of things. So I've scaled on virtualization layer, if you will, which is kind of what default Amazon CloudWatch gives you, CPU, network throughput, that kind of thing. My major suggestion would be to add a custom CloudWatch handler, inject Linux load average, is something that's a bit more coherent to your business logic. And then auto-scale and just about every other Amazon option allows you to hook into an SQS queue. And so one of the links that I had was an AWS SQS alert system. And not only does that alert, but it also uses PyChef to delete nodes and clients from hosted Chef. Because essentially what will happen is during intense periods of elasticity in your clusters, you may end up deleting a node, a new machine comes up, tries to use that same IP address, and if that's what you've used for your client name, you'll get a conflict, and that's not good. And so if you're having race conditions that are that fast, so much that your chef infrastructure can't respond quick enough, then I would say, again, kind of go back to the cleanup recipe and generating an AMI so that the AMI that boots performs the least number of actions possible before the load balancer actually starts sending traffic. Anyone else?
If money was not an option, what appliances would you be using?
If money was not an option, what appliances would I be using? Honestly, I'd probably pay for Enterprise Chef because I spend a lot of my time architecting around the open source limitations of things. Open source push. Really, it's the value add. My general philosophy is that if it takes me about a week to do something, I should probably be using a service to do that. Because not only is it going to take me a week to develop, but what about the added maintenance? And again, this is coming from kind of living in a bubble as a single man ops dev team for a while. If you don't do that, you will not have momentum, and you will just add inertia as you go, as far as technical debt with maintenance and those types of things.
What limitations do you have from open source chef as opposed to paid chef?
Paid chef? Well, I tried running my own chef server for a while because hosted chef is slow sometimes, but it's great. It's always there. I in general count on it. But in trying to do things like use chef as a metadata server and things they're not necessarily meant to do, tried running my own chef server for a while. The community support is great for competing products. But that's really kind of the only major limitation that I found was official support, not community support, right? But it's an open source product. I really wish there were more cloud vendors, infrastructure as a service that provided model-driven, options. Rackspace with the new public OpenStack install has gotten way farther with that, and I'm definitely going to start considering using them in the future. But as far as a single person developer and be able to affect change in a business, you have to model define things.
To tag along with that, if you had to bubble up in one roadmap request on the open source side, what would take the headache off your plate the most?
That's interesting.
We're at the right place to
sure,
shout
yeah,
those out.
right.
Community sitting around us. So.
Yeah. So I think there's already some work being done on an etcd tie-in that makes the Chef DSL really usable and applicable and understandable as far as that goes. Because when people bring that up, I say, well, but that's just a metadata store, right? And that's what I'm using Chef for. It's just it's scalable and it's meant for that purpose, right? Again, going back to push out-of-band jobs so that we can do kind of orchestration within an application level. But all these things are coming, this year, pretty much over the past 3 months while, I've really been kind of focusing on this talk and reading and really trying to do best practices. So much has changed in the community and it's for the better. And a lot of the talk at this conference among everyone is how do we make things better? And I don't know if any of you guys went to the talk earlier about humane development, but how do we make these tools easier on the people using them? Not just the ones developing them, but the ones actually running the code. No, that's fine. I'm great. the demo didn't work, but I encourage everyone to, on your own time, pull that code. The instructions are 2 lines: bundle, install, break magic. And in theory, if the network hadn't failed on a package download, everything would have converged, and we would have had a MySQL master slave setup that was driven through a state machine in Chef server through essentially 3 Chef converges, right? You just run Chef over and over again, and eventually you get master slave replication.